Welcome to Silicon Valley Super Schools. Hello, young scientist. Today we are going to learn about some amazing rules that describe how things move in our world. These rules are called laws of motion, and they were discovered by a very smart scientist named Isaac Newton. He was curious about why things move the way they do, and he came up with 3 simple laws that explain everything from how a car starts and stops to how rockets go to space. Let's find out what these laws are and see some examples that you can relate to. Newton's first law of motion. The first law of motion says that an object at rest stays at rest, and an object in motion stays in motion at the same speed and in the same direction unless acted upon by an unbalanced force. That sounds complicated, but it's actually very easy to understand. Let me show you. Imagine you have a toy car sitting on a table. According to Newton's first law, an object at rest will stay at rest unless acted upon by an external force. This is called the law of inertia. In simpler terms, things like to keep doing what they're doing, whether it's resting or moving. But what happens if we apply a force to our toy car? Wow! Did you see that? The car started moving. Why? Because we applied a force to it. Newton's first law tells us that an object in motion will keep moving in the same direction and at the same speed, unless acted upon by an external force. Now, let's talk about another example that you might be familiar with: kicking a soccer ball. When you kick a ball, it starts moving, right? But have you ever wondered why it eventually slows down and stops? This happens because of friction, which is another force acting on the ball. Newton's first law tells us that when the force of friction becomes stronger than the force that was initially applied, it slows down the ball and brings it to a stop. So, what did we learn from these examples? We learned that an object will not move by itself or stop by itself unless there is a force acting on it. We also learned that an object will not change its direction unless there is a force acting on it. This is what Newton's first law of motion tells us. Now let's see about the Newton's second law of motion. The second law of motion says that the acceleration of an object depends on the mass of the object and the amount of force applied. Acceleration means how fast an object changes its speed or direction. Mass means how much matter an object has. Force means how hard you push or pull an object. Let's see an example of this law. Here we have 2 balls, one big and one small. They have different masses. The big one has more mass than the small one. I am going to push them with the same force and see what happens. Did you see that? The small ball went faster and farther than the big ball, right? Why is that? Well, because the small ball has less mass than the big ball, it is easier to accelerate. The same force makes it change its speed more than the big ball. Now let's try another example. Here we have 2 balls of the same size and mass. I am going to push one with more force than the other and see what happens. Did you see that? The harder pushed ball went faster and farther than the softer pushed ball, right? Why is that? Well, because I applied more force on one ball than on the other, it changed its speed more than the other. So, what did we learn from these examples? We learned that an object will accelerate more if it has less mass or if more force is applied on it. This is what Newton's second law of motion tells us. But how can we calculate how much an object accelerates when we apply a certain amount of force on it? Well, there is a simple formula for that. F equals to ma. Suppose we have an object of mass 5 kilograms that is accelerating at 3 ms-2. We want to find the force acting on the object. To do this, we just need to plug in the values of mass and acceleration into the formula F equals to ma and calculate the force. Mass equals to 5 kilograms. Acceleration equal to 3 ms-2. So, 5 multiplied by 3 is equals to 15. This means that the force acting on the object is 15 Newton. Congratulations! Now you got an idea about Newton's first law and Newton's second law. Now let's discuss about the Newton's third law of motion. Let's see an example of this law. Here we have a person walking on the ground. When the person walks, he pushes down and backward on the ground with his feet. This is the action force. The ground pushes up and forward on the person with its reaction. This is the reaction force. These two forces are equal and opposite, so they make the person move forward. So, what did we learn from this example? We learned that whenever we push or pull something, it pushes or pulls us back with the same amount of force in the opposite direction. This is what Newton's third law of motion tells us. Now let's see the equation of Newton's third law of motion. The formula or equation for the third law of motion is Fa is equals to Fb, where Fa is the action force exerted by one object on another object, and Fb is the reaction force exerted by that other object back on the first object. This formula means that whenever two objects interact with each other, they exert equal and opposite forces on each other. These forces are called action-reaction pairs. For example, let's say we have a person pushing a box with a force of 20 Newton to the right. According to the formula, the box will push back on the person with a force of minus 20 Newton to the left. These two forces are equal and opposite, so they cancel out. Here is a simple question and answer based on this formula. Question. A person pulls a rope with a force of 50 Newton. The rope pulls back on the person with a force of A 0 Newton. B 50 Newton. C minus 50 Newton. D 100 Newton. Answer. According to Newton's third law of motion, whenever one object exerts a force on another object, that other object exerts an equal and opposite force back on the first object. Therefore, if the person pulls the rope with a force of 50 Newton, the rope pulls back on the person with a force of minus 50 Newton in the opposite direction. The correct answer is C minus 50 Newton. So, what did we learn from these examples? We learned that whenever we push or pull something, it pushes or pulls us back with the same amount of force in the opposite direction. This is what Newton's third law of motion tells us. In this video we have learned about 3 laws of motion that describe how things move in our world. These laws are Newton's first law of motion: an object at rest stays at rest, and an object in motion stays in motion at the same speed and in the same direction unless acted upon by an unbalanced force. Newton's second law of motion: the acceleration of an object depends on the mass of the object and the amount of force applied. Newton's third law of motion: for every action, there is an equal and opposite reaction. We have also learned some equations or formulas that help us calculate and understand these laws better. These equations are F equals to ma for the second law of motion. Fa equals to minus Fb for the third law of motion. These laws are very useful and important because they help us understand and predict how things behave in different situations. They also help us design and invent things that use motion, such as cars, planes, rockets, and more. I hope you enjoyed this video and learned something new. Stay tuned with Silicon Valley Super Schools for more videos. Thank you for watching and have a great day.